Okay, good evening, class. Yes, now I'm getting to respond to the question I sent you. The first question, which was question 3. It asked 3.1 says, what is a normal force? Of course, it's asking for the definition of a normal force. And as you know it, a normal force is what is this? The force exerted by the surface on an object that it's in contact with. So once an object is placed on top of a surface, once an object is placed on top of a surface, that surface exerts a force on that object. So that force it exerts on that object is called our normal force. This is what we call our normal force. So whenever there's an object on a surface, that object exerts a normal force. Then let's go to 3.2. 3.2 says draw a vector diagram. It says, a vector diagram. It says draw a vector diagram, right? So a vector diagram, of course, we have our what? Our ball over here. This is the 5 kg. It symbolizes the 5 kg, right? And then we have our forces. Of course, we have F. You see, this is the force which was drawn on that 5 kg, right? To 20 degrees. Remember, you cannot draw this one straight. It cannot be horizontal, this F. Reason being is that in the diagram, it was drawn 20 degrees from the what? Horizontal. Our horizontal is here. It's a straight line on the x-axis. You see? So now with this F, we have to draw it 20 degrees. We just estimate. It's not that we have to use a protractor or anything. We just estimate and put it at an angle. That's all it means. So we cannot make it vertical. However, you can add a dotted vertical line and a dotted horizontal line and a dotted vertical line, which are the components of the vector diagram. When we resolve the components of a vector diagram, as you all remember how to resolve a vector diagram. And what is this? A vector quantity. You know how to resolve it, right? So now we resolved it, which this is not necessary in your, what is this? Your diagram. It's just I put it there so that when I explain the other questions, you'll be able to understand and see what's going on. Next, we have our what? Our normal force. Normal force is the force exerted by what? The surface. So this force will always act upwards. It always acts upwards. Then we have our weight. Our weight will always act in the opposite direction of our normal force. It all depends on what? The position of the surface. This surface is what? Horizontally straight, meaning it will act horizontally, vertically upwards, the normal force. While our what? Our weight will act vertically downwards. So this is our weight right over here. Every object has a weight. Weight, how do we calculate weight? Weight is, what is this? The mass of an object times gravity. Gravity is 9.8. It's constant. The gravity of the earth is 9.8. So everything is drawn to the earth at 9.8 meters per second. It's constant. Then we have FF, which is our what? Our frictional force. You can just simply write F, but I like using FF, abbreviation, stuff like that. And then we have tension. Tension force. Tension force is only found whenever there is a string or rope. Anything that can be pulled. Yeah, you see. Whenever we are pulling something, whenever there is a force at the other opposite end of an object and then at the other side of an object, pulling the thing apart, that is tension. Tension is a pulling apart force. So whenever you're pulling something apart, there is tension acting upon that thing. So this is our vector diagram over here. And then let's move on to 3.3.1. 3.3.1 is asking us to calculate what? The tension. So to calculate the tension, we will not look at the 5 kg. We will look at the 2 kg. We'll use the 2 kg diagram to calculate, because the 2 kg, only forces acting on the 2 kg is what? Tension and weight. It's weight. It is not balanced on the surface, hence there is no what? Normal force, right? So now we look at this. Remember, we're using what? The second law. Newton's second law. Newton's second law says F net is equal to what? Mass times acceleration. So our F net is what? F net is the sum of all the forces acting on an object. So the sum of all the forces acting on an object is what? Tension minus what? Weight. Because tension and weight are in opposite directions. That's why we subtract them from one another. They are not in the same direction. If they were in the same direction, we would have added it. But as you can see here, we are subtracting it. So that tension minus weight is equal to what? The mass times the acceleration of the system. We are given that the acceleration of the system is what? 2 meters per second. And our weight of the block is what? 2 kg. So it's 2 times 2, as you can see over here. And then our mass of the block is what? Remember, calculation of weight is what? Mass times what? Gravity. Mass times gravity, what is it? 2 times 9,8. So tension minus 2 times 9,8 is equal to what? Our mass of the block times its acceleration, which is the acceleration of the system. The whole system accelerates at the same rate. No part of the system accelerates faster than the other or slower than the other. They all accelerate at 2 meters per second. So it's 2 times 2. So now we move on. T minus 19,6 is equal to what? 4. And then we further move on and say T is equal to, you know your maths, right? In maths, what happens? Now, since we're trying to solve for T, what do? We carry over 19,6 to the other side. Once it crosses the other side, its sign changes. You know your maths, right? So when its sign changes, it becomes what? 4 plus 19,6. So tension, which is T, is equal to 4 plus 19,6. And then you punch that in your calculator if you can't do it with your head, which is what? T is equal to 23,6 newtons. Remember, our unit for force of vector is what? Newtons, guys. Okay, so now we have answered 3.3.1. Let's move on to 3.3.2. So for 3.3.2, there'll be a lot of explanation for me to do. But now let's look at it. Right. Remember, 3.3.2 is asking us to solve for the force. So we need to know the force being applied onto the 5 kg block. That force that we're applying in 20 degrees from the what? Horizontal. We need to know what is this, the magnitude of that force. In scientific term, we call it magnitude. Okay. We know that force is what? 20 degrees from the horizontal. So our theta is 20 degrees from the horizontal. First of all, let's look at this diagram. This is our 5 kg block. And then here's the what? Force. The force is F. Acting what? 20 degrees from the horizontal. So here's our horizontal line here. So now we resolve this vector. Let's resolve it. When we resolve it, we'll have Fx. It's moving in this direction. So of course, our Fx will move also in this direction. Then our Fy, because it's moving also upwards. So it will have a what? Upward and a what? A horizontal force. Okay. So now, remember, Fn is equal to what? First of all. Okay, wait. Let's solve for Fx. Let's see. Fx is equal to what? Let's say we want to calculate Fx. How would we calculate Fx? We would have to use our trig ratios, which we learn in math. Trig ratio, remember, this side is Fx is which side? The adjacent side. Adjacent over what? Hypotenuse. Adjacent over hypotenuse is what? Cos. Meaning, let's go down here. Okay, so that means we'll say what? Cos 20 degrees is equal to what? Fx over f. Over f. So now we want to solve for fx. For fx, means we must multiply both sides by f. Both sides by f. Therefore, f times cos 20 degrees is equal to fx. So wherever we have to calculate for fx, we know that what? Fx is equal to what? This, which is f times cos 20 degrees. And then let's say we're looking for y. For y, it would be what? Y is our opposite side. So opposite over adjacent. Opposite over adjacent is what? Sine. Let's go up. Sine is what? Sine 20 degrees is equal to what? Fy over f. Then what do? We want to solve for f. For what? Fy. To solve for fy, we multiply both sides by f. So that means f times sine 20 degrees is equal to what? Fy. Guys, we need to know our maths. Especially when it comes to Newton's law, we really need to know our maths. Otherwise, it will be a big problem when it comes to the calculations. It won't be very easy. Okay? So now, since we have understood that, let's go to question 3.2. 3.2 is asking for this F to find out its magnitude, the force. So to find out the force of this, we need a ratio. We need an angle. You see, we have to use one of these sides. our trig ratios to calculate. Because number one, remember, F net is the total, is the sum of forces acting on an object. So we have to use the horizontal. What is this? The horizontal force is acting on this object. Or we can use also what? We can use the what is this? The vertical, but I prefer we use the horizontal, because for the horizontal, we don't have many unknowns. We have friction. Friction is given to us in the question, which is 10 newtons. Then we have already calculated our tension, meaning the only unknown we have is our what? F of x. You see? It's F of x as compared to what is this? To the normal force. We don't know what the normal, for vertical, we don't know the normal force. We don't know Fy, but we know our weight. Our weight is easy to calculate, which is what? Our weight is mass times gravity. We know that one is easy. So we cannot use two unknowns to calculate. But here, since we have one unknown on the horizontal, it will be much easier. So that means F net is equal to what? MA. F net, sum of what? The what force is acting on the object. So F net is what? Fx. Fx, you see Fx over here? And then tension, we have tension on this side. As you can see in our previous question, there's tension and then there's Ff. Tension is always opposing the motion or opposing the force applied. Tension and also friction. Friction is always opposing what? The force applied. Friction goes in the other direction. So that means friction and what? And tension will be subtracted from our what? Fx, because Fx is the only one going in that direction. So it's Fx minus tension minus Ff is equal to Ma. Remember, guys, we know what is tension. We have calculated tension. The previous question is 23.6, and we are given what is this? Friction. Friction is what? 10 newtons. Then we know to calculate, we know the mass of the object, of course, which is 5, and the acceleration of the system we're given is 2 newtons. I mean 2 meters per second. And then we know, remember, we have got the ratio of this. We know Fx is equal to what? Remember how we proved it here? Using our math, our trig ratios, that Fx is equal to what? F times cos 20. So we just put F times cos 20 there, because we are trying to solve for F. We're not trying to solve for Fx. We're trying to solve for what? F. So we have to substitute now. So now our only unknown is what? F, because we know cos theta is equal to what? Cos 20 degrees. We know that. So now, of course, negative 23 minus 10, it becomes what? We take all of this to the other side. Negative 23.6 minus 10, which is negative 33.6. When we take it to that other side, it becomes F cos theta is equal to 10 plus 33.6, which is equal to what? 43.6. So F cos theta is equal to what? 43.6. What is our theta, guys? Our theta is the angle at which the force is applied from the horizontal, which is 20 degrees. So now we put the 20 degrees there. We divide both sides by cos 20. Divide this side by cos 20. So when we divide both sides by cos 20, we are left with F, which is what we are looking for. We're trying to resolve for F. So that for F is equal to what? 46.40 what? Newtons. Do you understand that? If you don't understand, you can play over the video again. Yes. So now let's move on to the next question. Okay, the next question is what? Calculate the coefficient of what? Frictional force. Guys, remember, to calculate frictional force, we have our what? Fk, which is frictional, kinetic. They're talking about kinetic friction. To calculate kinetic friction or static friction, we always have our what? Our mu, which is what? Mu is a what? It's a symbol for what is this? The coefficient for friction. So here, what is this? We have mu k times normal force for kinetic friction. So to get this is our coefficient. This is what they're asking us for. We need to know the formula for kinetic friction, so that we can understand what we want to do, what they're asking us for. So now we have our formula here. Now we know they are looking for what? Mu k, which are our coefficient of what? Kinetic friction. So first of all, we cannot solve because now we don't know what is mu k. We don't know what is normal force, but we know what is our what? Our kinetic friction, which is 10 given to us in the question. So now we first calculate for normal force. To calculate for normal force, we resolve our what? Our vertical vectors, our vertical forces. Vertical forces are what? Normal force, weight, and Fy. We know Fy. Remember how we solved it. Fy is what? Fy is this side. To get Fy, it's what? We say sine 20 degrees is equal to what? Fy over Ff. Remember, sine is opposite over hypotenuse. So then we're looking for Fy, multiply both sides by F. It gives us F times sine 20 is equal to Fy. So that's why we have Fy is equal to what? That's why when we substitute negative F sine 20 degrees. And you know how to calculate weight. I'm going to repeat again. Weight is what? Mass times what? Gravitational acceleration, which is 5 times 9,8 minus F sine 20 degrees. So 5 times 9,8 is what? 88,2 minus. Remember, guys, we already calculated our F in the previous question, which is 46,40. Don't make the mistake of saying, oh, we don't have that. We have it. So that times what? Sine 20 degrees. Then we move on to what? We calculated, put in our calculator, it will give us what? 72,33 newtons. So our normal force is 72,33 newtons. So now that means we can go back to our what? Formula for what? Kinetic friction and solve. So now we have our formula for kinetic friction. We don't have the normal force only. So that means Fk is equal to mu k times normal force. Our Fk given to us in the question is 10 is equal to mu k. And then our normal force, which you calculated above. So that means mu k times normal force. We divide both sides by normal force because we are looking for mu k. We have to isolate mu k, solve for mu k. It's like solving for x, algebra. Yes, it's our algebra. So that means now we must divide both sides by 72,33. Our mu k is what? 0,14. I'm not sure whether there are any units for our coefficient, but I don't think. You don't have to write any. There are no units for coefficient. Yes, we don't use any units. You just know that it's the coefficient. You don't have to write units. So you just write your unit, your value, and you leave it. That's it. So that's question number 3, guys.